JUnit is a habit, not an afterthought. JUnit test suites and the Launcher API. Lab 7 overview. JUnit test suites and the Launcher API. The goal of Lab 7 is to teach you how to compose JUnit test suites, launchers, and a test engine. This is a very complicated lab, the most advanced topic of this course, and this requires your sharpest attention and even utmost dedication. The code for the utility library is available from the course's GitHub account at https://www.github.com/Anton GitHub /GRG-001 JUnit as a habit. You should have the code for the utility library downloaded as of Lab 1. No changes are needed for Lab 7. We will explore the following annotations provided by JUnit to write test suites: @runWith, @select classes, @include class name patterns, @exclude class name patterns, @select packages, @include packages, @exclude packages, @include tags, @exclude tags. So please note that the test suite API is stuck at the JUnit 4 level and therefore cannot take advantage of the JUnit 5 new kind of features. It hasn't been brought up to the level of JUnit 5 and it does not take advantage of the new Jupyter platform. However, it is still a very robust and powerful way to write kind of declarative test suites using annotations. In addition to composing test suites, we will also explore writing programmatic test suites and integrations by using the Launcher API, which we will talk about on the next slide. We will explore the following concepts of the Launcher API: Launcher Discovery Request Builder class, Launcher Discovery Request class, Launcher Factory class, Launcher class, Class Path Resource Selector class, Class Path Root Selector class, Class Selector class, Directory Selector class, Discovery Selectors class, File Selector class, Method Selector class, Module Selector class, Package Selector class, Unique ID Selector class, URI Selector class, Class Name Filter Interface, Package Name Filter Interface, Test Plan Interface, Test Execution Listener Interface, Test Execution Summary class, Test Engine Interface, and Hierarchical Test Engine class. This last two we will also use to implement a custom, simple yet complete test engine. So we're using the Jupyter test engine and we will write a custom and yet complete, separate, our own test engine. In addition, we will explore the test descriptor class, node interface, legacy XML report generating listener class for parsing results, login listener class for login, summary generating listener class for parsing results, launcher config class, and engine test kit class to test our custom test engine. Stay sharp. This is an advanced topic that will separate you from developers who write unit tests and nothing else. You are on your way to becoming a JUnit advanced practitioner, a JUnit master, and it is worth it. Good luck. We are beginning the last lab of the course, but prior to getting started with its content, we need to clean up after lab number 6. Let's go to our main project and let's basically delete our test package. We can do it like this. We can delete it. And let's delete JUnit platform.properties file. Right, and let's rebuild our project. All right, everything seems to have gone well. Let us now go to, well, actually we don't need to do that. Let's leave the GRG-001 JUnit as a habit extension jar in place. We are not going to use it, but it can be safely left alone. Now let's recreate our package. Tag getRealGoodUtil.test, and we're going to be using this package to populate our common set of 5 test classes for lab number 7. We're also going to have to add, let's actually go to project website, test suite code. And we are going to need to create tag.getRealGood.util.suite package, or we can actually create tag.getRealGood.util.test.suite package. Doesn't matter. And we'll need to create these 2 test suite files. And we'll also need to download the JUnit platform runner version 1.7.0 in order to enable JUnit 4 runner. So let's go to unit test code now, objects test.java, lab number 7. Let's study the unified diff. There isn't really much that we need to change. Already, just a second. All right. So let us study the unified diff by stopping the course if necessary. Then let us go to the full file. Let us copy it and let's create objects tests class. All right, let's delete whatever's in there and let us put what we need to put in here. The only thing I see, everything's fine. The only thing I see we'd like to have, because we're not using extension logic anymore, we'd like to have an initialized log file. So let's go back to the unified diff and just do this line. Actually, let's just do this line here, like this. And let's copy it and let's change this line of code like this. And let's press Alt Enter to import the log refactory class. And we are done. This is a minor error that was here because this class was still thinking that we are using extensions, I guess. All right, so we are done with objects tests. Next, let's do strings tests. Let's create it. Let's delete whatever's in there. Let's go to the project website. Let's go to strings tests.java. Let's go to lab 7. Let's study the diff. And you can see we have some tag annotations that we deferred from lab 5. We're going to be using it in lab 7. Let's click on copy of the full file and let's paste the full file into the editor. And let's see that everything is fine. The tag add tag annotation is found. Everything looks okay. The next is methods tests. Right. Let's delete whatever content is in there initially. Let's go to maths test.java on the courses website. Let's go to lab 7. For lab 7, maths tests, collections tests, and arrays tests do not have any functionality related to lab number 7. And we're using only objects tests and strings tests, but for completeness sake, we're going to use everything, as we always do. Alright, let's copy what we copied. Let's paste what we copied on the project website. And the next is going to be collections tests. Alright, collections tests are here. Collections tests. Lab 7. And again, nothing meaningful in terms of... Oh, actually I am mistaken. In collections tests we have a @tag annotation, so we are using some of it. Let's go to full file, copy, and let's paste it. Everything looks good. Let's do arrays tests. I wonder if I made a mistake, and we are using arrays tests as well. Let's delete what was in there initially, and let's go to arrays tests.java. Let's go to lab 7. Let's take a look at the unified diff. And we are using that tag annotation. Good. So let's go to the full file. Let's copy it and let's paste it in here. Alright, now let us go to the test folder and let us create a JUnit-platform.properties file. Let's go to, well, what's wrong with this? Oh, go here. Alright, let's go to objects-test.java, lab 7. Let's scroll all the way down to JUnit-platform.properties file. Let's copy it and let's paste it in here. I do not believe we are going to be utilizing this for lab number 7. But it's still, for the sake of completeness, something that we should do. Let's rebuild the project. Alright, and let's see the results of the build. It was correct. Let us now run the tests and see that all of them pass. Alright, all 214 pass just fine, and we are good to go. We are not going to use any more extension code from lab number 6, so let's go ahead and remove it. We don't have to remove it, but we might as well. Let's go to libraries, let's highlight this, and let's click minus and OK. Let's now click apply, let's rebuild it, and then let's run all the unit tests. Let's run all the unit tests. Let's see. All right. Okay, they all pass, so we are ready to start creating test suites for part 1 of lab 7. In part 2 of lab 7, we're going to do a custom test engine, and we're going to test that custom test engine. And in part 3 of lab number 7, we're going to write a simple launcher and launch our custom test engine from the command line, and by using the actually main method of our class. Actually, I think from the command line we might launch it in the second part, but we'll see. So we are ready to proceed. For the second part, we'll need to import one more auxiliary project, and for part number 3, we'll need to import yet one more auxiliary project to keep everything separate and to keep everything well defined and clear cut and clean cut. So I will see you in the next video clip where we will get started on part 1 of lab 7 by creating a couple of test suites or suits. In this video clip, we're going to explore how to create a test suites by using JUnit 5 platform. In actuality, test suites are an atavism from JUnit 4 platform, kept around just because they're so tremendously convenient. Now, in the previous video clip, we have created our unit test classes with unit tests, edit JUnit platform.properties. And now what we have to do, we have to go to the project website, go to test suite code, and we are going to have to create this package. Let's copy it. Let's go back to the IDE and let's create a new package. Right click on test, new package. Control V. Alright, we have the suite package tag get.getRealGood.util.suite. Let's go back to the website for the course. Let's take a look at the object tests test suite.java. I apologize for this naming mesh. Alright, let's copy this name. Let's go to suite, create new Java class. Then let us delete what's in there. Let us go and copy this code. Let us paste it. Now, if you're not seeing that everything's fine, don't worry for now. We're going to import the appropriate libraries soon. Let us go back to the project website and let us add custom test suite.java to our project. New Java class, custom test suite, delete everything that's in there, and now copy what is in the file and paste it in here. Now let us go back to the project website and take a look at step 2. You must also add the following library to the list of the project's libraries to enable JUnit 4 runner. And the string for this library is org.junit.platform, column JUnit-platform-runner, column 1.7.0. So we're going to copy the string. We're going to go back to the project. We're going to go to File, Project Structure. We're going to go to Libraries. We're going to click the plus sign. We're going to select from Maven. We're going to press Ctrl V. Excuse me. We're going to want to get the transitive dependencies, sources, Java docs, and we're going to click OK. We're going to add the Choose Modules dialog. We're going to select our project, click OK. And we have imported another library into our project. And we see now everything is going to clear up. Alright, in the next video clip we're going to get to playing around with the test suites, and we're going to show you how to select packages, select classes, and filter packages, classes by name, by tag that might be associated with it, etc. As we created the custom test suites, now is the time to run them and also to understand the various selection and configuration options which we have. Let's take a look at object tests test suite.java. Here we have the mandatory @runWith annotation, passing in the value of JUnit platform.class. You can apply it to a test class if your test class is written using JUnit for semantics. None of our test classes are written using JUnit for semantics. All of them are written using JUnit 5 ways, and so we are constrained to using it only on test suite classes. Alright, here we have add suite display name object test suite. This would be the name under which any reporting software would present this test suite. I heard it weird that IntelliJ IDEA does not integrate this annotation. I'm sure it is by design, but it doesn't do so. So when we have the results here of the test runs, nothing that we put in here is visible anywhere, and neither it is in the log. But usually if you use like command line or something like that, this should be visible. Add use technical names annotation is an annotation that causes the reporting to use slightly more technical names, such as using the main test class and add nested test class conjoined together in the report. Nothing major, but just more technical names, and if you use it, use technical names, it will completely override this annotation, that suite display name. Then we have add select classes annotation, and we are selecting our object tests.class to run. So we would expect this test class, its two add nested inner classes and all the 4 unit tests to be picked up by this test suite and nothing else. So let us try if that is indeed the case. Alright, and that is indeed the case. As you can see, the technical name, if we do not do add use technical names, we would just get something is not null here, is null here, we wouldn't get objects test. So minor differences. Alright, so that's our object tests test suite. A very simple test suite. We just pick up one test class to run, and that's what it does. Now let us go to custom test suite, and we'll spend quite a bit of time on the custom test suite So now we are going to take a look at the custom test suite, the Java test suite. Let's take a look at it. Again, it begins with @runWith JUnit platform.class. It has add suite display name custom suite, which is not picked up anywhere. It has add select packages, and we select precisely this package, all of its 5 test classes. But then we're going to start filtering it, and the first type of filter we're going to take a look is going to be add include tags, in which case we're including custom tag, and add exclude tags, in which case not custom. And let's run it and see what happens. Alright, so we see that we got the entirety of the strings tests class and all the unit tests, and then we got one unit test for each of other 3 test classes. So let's take a look at the strings test class, and we can see immediately that the entire test class is annotated with add tag custom. So there is nothing, no other tags in here, and therefore the entire test class is picked up. Let's go to collections tests. Let's take a look at throws tests, and we see that in throws tests, basically one unit test method is annotated with add tag custom, and so that is the one which is picked up. Let's go to objects tests. Is null, and here we can see that the add nested inner class is null is annotated with add tag custom. So if that were the complete picture, both of its unit tests would have been picked up. However, one of those unit tests is annotated with add tag, not custom, so it's skipped, and this one is picked up. We can see that it is null, nullable, null, boolean, and this one is null, nullable, null, boolean, which is picked up. Let's go to arrays tests is empty tests, and let's see that one of its tags is annotated as add tag custom, or rather one of its unit tests is annotated with add tag custom, and so that's the one which is picked up as empty common array boolean is empty common array boolean. So that's excuse me, that's how basically the add include tags and add exclude tags filtering works. Let's take a look at other filtering capabilities. Well, first let's take a look at the selection capabilities. We have select packages, which we're using here, and select classes. So let's select a class in addition with select packages. Select classes. Let's select the class objects tests, or rather not the objects tests, but mess tests class. And let's see what, well, let's make mess tests public. We always have to do it if we want it to be picked up. Let's make it public so that it could be importable into a different package, which is where our test suites are. And let's take a look actually what will happen now. So remember, where is it? Remember, this is the result. We got one unit test in collections tests, one unit tests in objects tests, and one unit tests in arrays tests. And we got everything picked up in strings tests. So let's now run the unit test with the addition at select classes mess tests.class and see what happens. What we see is that the entirety of the strings tests got picked up, collections tests got picked up as before, objects tests got picked up as before, and arrays tests got picked up as before. So the addition of select classes mess test.class was considered, but ultimately it did not have a custom tag applied anywhere, so it was basically filtered out. Alright, let's do now comment out select packages. I leave just select classes, and let's do again with the tag filtering and see what happens. And you're welcome to venture a guess what happens while this is running. Well, the filtering mechanism skipped everything. So please notice it says test pasts 101 test, but no test was picked up, so it's just a slight misnomer here on the parts of the UI. Alright, so that is how select packages and select classes work. Just something to notice, we are using this, we're providing a literal value. We don't have to, we could provide for all of this selection and filtering annotations, we could provide arrays as well. For example, in this case, we would expect 2 test classes to be picked up and run. Let us see. And that's exactly the case. We have the full measure of unit tests in object test class, and we have the full measure of unit tests in the mass tests class. So we can provide one value, or we can provide a list values or an array of values to all the selection and inclusion and exclusion annotations for test suites. Alright, let us now comment this out, and let us again use select packages. Let's run it. Now we will get all 5 test classes run. As we can see, all 214 of 214 tests have run. Alright, but now what we would like to do, we would like now to create a new package, and we are going to call it include. So the full name would be tag.getRealGood.util.test.include. And we're going to put arrays tests in this include package. And we're also going to create a package called exclude. And we are going to put collections tests into the package exclude. Alright, let's close everything but custom test suite. And let's now try to do this. Include packages include. Exclude packages. Pardon my coughing. Alright, exclude packages tag.getRealGood.util.test exclude. And let us run it and see what happens. Alright, only the package which we chose to include had its test classes discovered and run. Even though we selected the parent package, the 3 test classes we saw in the parent package were not discovered and run, even though we selected them. So that is something to note about how the add include packages and add exclude packages work. So if you wanted to include the packages from the parent directory, we would do it like this. And that's the only way to do it. It doesn't automatically include it if we use add include packages. Alright, you can see that in this case, not only arrays tests were picked up, but mass tests, objects tests, and strings tests. Now this was still excluded. Now what if we didn't exclude it? What would happen? Well, if we didn't exclude it, we would get all 5 picked up. So the fact that we selected this package and then included this package and did not exclude the exclude package means that the exclude package would be picked up in this setup, in addition to the include package as well, which in this case obviously we don't need to include verbatim. In fact, we don't need to include anything in this case. Alright, and now let's do just the exclude packages and exclude the tag that get real good that util.test that exclude package and see what happens. Alright, and so it did exclude the collections test class, but included everything else as per our selection. So that is something to keep in mind, that the add include packages and add exclude packages modify with some quirks our add select packages selections. Alright. Now that we have completed the review of add include packages and add exclude packages, let's take a look at what else we could take a look at. So we've taken a look at include packages, at include tags, at exclude packages, exclude tags. The next thing to take a look at is we've taken a look at select classes, we've taken a look at select packages, but we have not yet taken a look at include engines and exclude engines, and include class name patterns and exclude class name patterns. So let's take a look first at include class name patterns. Right. Include class name patterns. What if we wanted to run just, for example, strings tests and objects tests? Well, in this case, we would need to do something like this. We would write a regex for each one of those. And please keep in mind the regex is related to the fully qualified class name. Not just the name of the class, but it's fully qualified class name. Right, so this regular expression would be expected to pick up strings tests, and this one would be expected. Let's actually do it like this: objects tests and strings tests. Right, let's see if we wrote our expression correctly. So we selected this package. It has 5 unit. It has 5 test classes, but we are interested only in classes with these name patterns, which we wrote using fairly simple regular expressions. Let's run it and see what happens. Alright, and indeed our runtime picked up objects in their fullness and picked up strings tests in its fullness. Alright, so the next one we would like to see is exclude class name patterns, and let's comment this out, and let's say that we would like to run everything except objects tests. And remember, we can add one value or a list of values here. So let's see how it works now. Alright, we got strings tests, arrays tests, collections tests, mass tests, but we don't have objects tests. And so everything worked as it should be. Now let's give contradictory directions to the runtime and see how it works in this case. Alright, and it works correctly. It picked this package, it picked two class names, and then it removed one of those, and it only ran this class name, which is the appropriate behavior. Alright, this concludes our add include class name patterns and add exclude class name patterns review. Let's now take a look at include engines, and let's say that we remember the two engines are JUnit Jupyter and JUnit Vintage. So we're including, we are stating that we want this test engine to run our test suite. Let's see if it does so. And it obviously should run all the 5 test classes. And it does that. JUnit Jupyter works as it should. But what if we included JUnit Vintage? Let's see if it does that. Remember, we wrote our unit tests according to JUnit 5 paradigm. Yeah, and it ignores it. Excellent. But what happens if we now include both of them? Now remember, keeping things as simple as possible but not simpler, and as robust as possible but no more robust or complicated, is very important. So you would not likely come up with something like this. And if you do, you should ask yourself why. But let's see how it works. Alright, so the first one didn't really run, but the second one ran and did the right thing. Alright, so what happens if we exclude now? Well, let's comment it out. If we exclude this, exclude engines. If we exclude both of them, and remember, only 2 of them are available for now. Alright, and nothing happens. There is no engine that can run. But what if we exclude only one of them? The vintage one. Alright, everything works as we would expect. Alright, so we have seen the varied selection and filtering behavior of how we put together test suites. It is really quite magnificent. Later on, in the third part of lab number 7, we are going to see the launcher API, which basically duplicates this functionality. However, how when the test suite concept is upgraded to JUnit 5, how it will look? Will this code be updated to run behind the scenes by using the launcher API, or will the launcher API be used directly in order to basically accomplish the same functionality? That is still to be seen. For now, just remember that you need to import an additional library to enable JUnit 4 runner. and you can create very robust and nice test suites for your usage. So this concludes our test suite expoundment. The only thing that is left to do in the next video clip is to use our tactile senses in order to retype several times various annotations related to the test suite. Now let's utilize our kinesthetic motor memory to retype some things so that we remember later on how to type the annotations related to test suites. Let's take a look if we need to add some annotations. We need to add use technical names. That's just about it. All right. Use technical names. Now let's comment everything out except that run with. And now let's go line by line, retyping it. Let us start with suite display name, and you can copy and paste what's between the parentheses. That is perfectly fine. Suite display name. Forget the parentheses. The parser is complaining. Alright, suite display name. Sometimes it happens, sometimes it doesn't. Alright, so we wrote it 3 times. Hopefully your motor memory memorized it. Use technical names. Use technical names. Use technical names. Please note that none of these annotations have the add repeatable meta annotation, so it gives errors if we repeat them more than once. Alright, select packages. Select packages. Let's select packages. We can just, I guess, do this. Right, we're done with select packages. Add select classes. We can just copy everything here. Add select classes. Add select classes. Alright, add include engines, and we can just copy what's in there. Add include engines. Add include engines, and of course we're repeating it 3 times for your motor memory to pick it up well. Add exclude engines. Add exclude engines. We could do it like a list, or rather an array, or like a literal. Add exclude engines. Alright. Add include packages. And we can copy what's in there. Add include packages. Add include packages. Alright. Add exclude packages. Alright, add exclude packages, add exclude packages. Alright, we're done with that exclude packages. Add include class name patterns. Add in, well, alright, add include class name patterns. Add include class name patterns. Alright. Add exclude class name patterns. And let's copy what we got in there. Add exclude class name patterns. And I repeat it without tiring and without fail. If you have the ability to take a class or to invest some money into a software package that will teach you how to type without looking and raise your typing speed, that's a very, very worthy expenditure of your time and resources. Include tags custom. Include tags, we can just type custom here as a literal. Oh. Include tags custom. Right, we're done with add include tags. Add exclude tags. Because the ability to type without looking with both hands with 10 fingers is virtually priceless. Exclude tags, we can do it as a literal, not custom, and exclude tags, not custom. Alright, and we have done everything except the add run with. That we will retype the GUnit platform.class. Run with GUnit platform.class. Run with GUnit platform.class. Alright, and we're done with the add run with annotation as well. In fact, we're done with all of them, and basically we are done with part 1 of lab 7. So I will see you in the next video clip where we get to write in our own custom test engine, using it to test some files or tests. And we're also going to write a few tests to test the test engine. So for part 2 of lab 7, we're going to write our own custom test engine, and we're going to test our own custom test engine. Alright, so let's take a look at what we have in terms of our projects for the course right now. You should have opened GRG-001 JUnit as a habit project, and also go to File, open Recent, and go to GRG-001 JUnit as a habit extension. Open it in a new window, and just take a look at it for last time for the duration of the course. We are saying goodbye to the main project and to the first auxiliary project. We have no need of it anymore, so please go ahead and close GRG-001 JUnit as a habit extension. Exit, and let us actually reopen the IntelliJ IDEA. It's opening on the second screen, so please wait a second. Alright, well, it's insisting it's going to open GRG-001 JUnit as a habit extension now, so that's alright. Let us check something out. Let's go to help about. And you see that I'm using at this point IntelliJ IDEA Ultimate 2020.3. So that is perfectly fine. We started with one version of IntelliJ IDEA, and as I was working on the course, I was upgrading to a different version. Any version really is fine. They're pretty much backward compatible. However, the versions of the JVM, JUnit, etc. Need to be kept the same as per instructions. Alright, let's now go to File. Well, let's actually now go to project website. Let's go to Test Engine Code, and let's take a look what's in there. Well, step 1 says clone or download the GRG-001 JUnit as a habit test engine project. This is the third project in the course that is required for Lab 7. So this is, in addition to main project and the first auxiliary project, this is the second auxiliary project in the course. At this point, we do not need the main project and the first auxiliary project, so we can just go ahead and copy this link, Ctrl+C. We can go back to our IntelliJ IDEA. Whichever project you have open is fine. We're going to replace this project. Go to File, New, Project from Version Control. Do Ctrl+V for the URL, and you can place it wherever you placed the main project and the extension project. So the first auxiliary project and this second auxiliary project should go in the same directory for simplicity. Okay, clone. We have it cloning. Alright, and where would you like to open the project? Let's open it into this window, saying goodbye to our first two projects we were working with. Alright, let's go to project, let's open it. And first and foremost, let's go and take a look at File, Project, Structure. We see that we're using the correct JDK, version 14.0.2. We see that we're using the correct modules, source, test, etc. We see that we have some more folders that I will explain shortly. Let us go to libraries at this point, however. So you can see that we have the org JUnit.Jupyter, column JUnit.Jupyter, not .Jupyter, -Jupyter, column 5.6.2. Library, you can see that it is in a central location. You can see .m2 here. So it was automatically picked up by the runtime. You can see that also you have this library and this library already in place. However, in your case, you're not likely to have it in place. So let me show you how to, if you see it underlined by red, it means that the IDE is expecting this library, but it is not in place. Let me show you actually how to correct this issue. If you see something underlined by red, it means that we have to do this. Go to the name and do Control-C. Then again, highlight this library, click minus, and do OK. Do plus, go from Maven, Control-V. You can see that we are getting this library back, and this library is needed to run a custom test engine from the command line, so from the console. Now we need the transitive dependencies, and let's do also sources in Java docs, and let's download it by clicking OK. We are going to add it to this project. So, and you can see it also loaded in a central location because you can see .m2. All right, let's take a look at the next library. So this library, you can see that it's in there because obviously when I was creating the content and I was creating the projects, I downloaded all of these artifacts, but you may not have them, and so you need to download them. And what I'm showing you now, if you have anything underlined by red, how to fix the missing library. So basically go here to name, Control-C, copy it, then highlight the library in this place and delete it. Now go to plus from Maven, Control-V, and we need dependencies, sources, and Java docs. That is good. And we're going to place it into the test engine auxiliary project. And so you can see it downloads it in a central location, which is what we would prefer, because any other projects that need it will pick it up automatically. So remember, you click on the minus sign to delete it. You click on the plus sign to create it. All right, and we are good in this regard. Let's see that our project builds fine. That is, all of our libraries are in place. All right, and it appears to be the case. Now let us take a look at the folders located within the project. Here we have the customary source folder, where we have the code for the engine and a custom test execution listener. Here we have some code in the test section, where we use the engine test kit to test our custom test engine. We have a tests folder where we have 10 testx.txt files, which are going to be containing the data which we will evaluate as our test. Remember that if you want to test Java classes, it is best to use JUnit Jupyter because it already does that. But if you want to do any other type of testing, pull data from a database, for example, pull data from a REST source, pull data from a text file, pull data from an XML file, instrument a Java class file before you test it, containing tests, etc., then you would write a custom test engine. The possibilities are virtually limitless, and this is what makes the JUnit not a framework but a testing platform, because it is very powerful in terms of what you can test, what you can say is a test, and what can be therefore tested by creating custom test engines. Alright, here we have meta-inf folder, services subfolder that you saw before, and two files, org.junit.platform.engine.testengine that uses the service loader mechanism to automatically register our custom test engine, and org.junit.platform.launcher.testExecutionListener file, which uses also service loader mechanism to automatically register a test execution listener or listeners. Alright, and because we have a meta-inf, you can easily basically come to the conclusion that we are going to make a .jar file out of this. And why are we going to make a .jar file out of this? So that we could import it as a library in the third part of our Lab 7 to be run by the Launcher API, but also so that we could utilize the console launcher class of Java JUnit 5 API, and so that we could launch our custom test engine from the console. And for that we have a command.txt which has our command line that we are going to use, and it has the arguments file which we're going to supply to our command line in this form. And here obviously you can see an absolute path to platform console standalone 1.6.0.jar. If you recall, we recently imported this library. That is the library which is required for using the console launcher and to running custom test engines on the console. Right, and in the args.txt that we're supplying to this command line, we are actually supplying the relative path to our GRG-001 test unit as a habit test engine.jar, which is created by building our project. Alright, so that is what we're going to be doing in part 2 of Lab 7. But before we go on, let us switch back to the project website and let us review actually the code base for our test engine project. So first we have a custom test engine configuration.java. We just don't reinvent the wheel, we just extend the Jupyter configuration because we don't really need to change anything here in this interface. Then we have a custom test descriptor. Each test has a test descriptor that has useful methods for manipulating the test, and we're writing a custom test descriptor that extends abstract test descriptor class. And you can see that basically we have a protected constructor, and we have a public getType class which returns in our case type.test. You can also return type container for more complicated types of custom test engines. And here we have getFileContent, which returns basically a list of strings representing files contents. Then we have the central class to our custom test engine, and it's called custom test engine.java. Here basically this class implements a test engine interface. Alternatively, one could extend hierarchical test engine abstract class, but we chose to do it from scratch to show you the full functionality of how it can be done. Now granted, this custom test engine is relatively simple. However, to do something really complex would be a disservice to the listener, because obviously the idea is to understand the concepts, not to write the most complicated and most capable custom test engine one could write. you can see that in this implementation we have a public getID method which returns custom test engine string, just like JUnit-Jupyter and JUnit-Vintage are the two test engines of the JUnit platform that we have seen before. Ours will be called in the same regard custom-test-engine. So whenever we, for example, refer to it, we would refer to it not as JUnit-Jupyter or JUnit-Vintage, but as custom-test-engine. Alright, we also implement the discover method where our tests are discovered, and we implement the execute method where our tests are executed and our registered listeners get notified about the life cycle of a test executing. Alright, now that we have written a custom test engine, we must test the custom test engine itself. For that we have custom test engine tests.java, and it uses the engine test kit class of JUnits. So basically we remember I showed you test 1 to test 10 within the project structure, within the tests folder of the project. What we do, we basically select this 10 files, we run the test engine, and then we look at container events. So we assert that one container was started and one succeeded in this regard. Next, our test, we verify how many tests pass and how many failed. So we get the same battery of test files, we run them, and then we look at test events, and we assert that out of 10 unit tests, 9 succeeded and 1 failed. So that's how we test a test engine. Alright, and here we have a custom test execution listener.java. Basically it implements test execution listener, and it listens to various points in the running in the unit tests lifecycle or test engines lifecycle. For example, test plan execution started, test plan execution finished, dynamic test registered, execution skipped of a test, execution started of a test, execution finished of a test, or reporting entry published for a test. Alright, so that in a nutshell is the description of our fairly basic but representative custom test engine. So let us return to our project. You should have a GRG-001 JUnit as a habit test engine here. It should build, it should have all these folders, console, meta-inf, source test, and tests. And at this point, we are ready to start actually looking some more through the source code and running the custom test engine on the console, and also providing this custom test engine as input into a launcher API implementation in part 3 of lab 7. In this video clip, I'm going to go through the code of what is essentially our custom test engine. I'm going to go through custom test engine, custom test descriptor, custom test engine configuration, and custom test execution listener. Alright, let us go through custom test engine, and let's see that it says custom test engine implements test engine. Let's do control click on test engine, and let's take a look at what interface this test engine represents. Right, it has several methods that you can read more about by being at the reader mode of IntelliJ IDEA, so that you can explore the Java doc. But in a nutshell, it has a getID, which we supply the string, which is a custom ID of our custom test engine. And it has a discover method and execute method. And then it has default methods get group ID, get artifact ID. Also has a get version. Alright, since those are defaults, we can leave them alone for our simple custom test engine implementation. And we can focus on the discover method first. Well, the getID method we implement, we just return custom -test -engine, and that's the string that will represent our test engine as a unique ID within the JUnit 5 platform. Let's take a look at the discover method. It takes an engine discovery request, and let's take a look at this interface. It's a fairly simple interface, and you're also welcome to spend more time in the reader mode by stopping the course and reading the Java doc. It provides a few methods to be implemented. Get selectors by type, where you select basically the type of objects that will select the test containers and the unit tests that you will later run. Get filters by type. Once you've selected your containers and tests, you want to filter them. You might want to exclude a portion of what you discovered, and that's where this method comes in handy. Then it says get configuration parameters, and you get the configuration parameters which you get from the JUnit-platform.properties file. And it's a little bit more than a hash map, basically where you would get properties, but you cannot set properties. So it's read-only hash map. That is the configuration parameters class. Now we have get discovery listener, which is a default method. It just returns a no up engine discovery listener. Let's take a look at the engine discovery listener interface. And engine discovery listener just provides one default method, selector processed. Whenever a selector finishes running, finishes its selection, this method is utilized to inform whomever might be listening that the selector has been processed, and you get the unique ID of the engine. You get an instance, you get a reference to the discovery selector, and you get a selector resolution result. The selector resolution result has a status, inner enumeration, resolved and resolved failed, and various basically convenience methods, static methods, resolved and resolved failed, etc. And you can take a look more in the reader mode of what this class represents. Alright, having taken a look at the engine discovery listener, let us go back to engine discovery request. We'll get back to this file soon enough, because we'll want to take a look at our discovery selectors and our discovery filters. But that will be in the next video clip. For now, we have taken a look at configuration parameters, engine discovery listener, etc. Let's go back to test engine and let us take a look at test descriptor. So basically, interface test descriptor represents a container or a test. And remember that our discovered tests are nothing more than a tree of containers, possibly contained containers, possibly even more contained containers to a certain level, and interspersed between them tests that our containers contain. And so it's a tree, and just like any tree, it contains hierarchies of test descriptor objects. So each test descriptor features a unique ID that we'll take a look at shortly. It returns a get display name, get legacy reporting name, it returns get tags, remember tags. Those are the tags. It returns source. It returns the parent of the test descriptor if available. It sets the parent of a test descriptor. This allows you to form a hierarchy of test descriptors. It returns get children, and it returns get descendants, so children, children of children, etc., onto the last level. Add child, remove child, so you can build hierarchy. Remove from hierarchy, you can remove this descriptor from hierarchy. Is root. Basically, if this is a tree, one of its nodes must be a root. Get type, and type can be either type.container or type.test, because we could have test descriptors describing containers or tests. Default methods is container, is test, may register tests, and this obviously refers to the ability to register dynamic tests, this particular method. Contains tests, prune, if it's a leaf, it can be pruned of the tree, find by unique ID, accept, and we have a functional interface visitor here that can function as a visitor for the tree-like structure. All right, we have an enum type, container test, container and tests, basically, and a couple more methods within the type that we can use. So you're welcome to spend some more time on the test descriptor interface. Basically, just keeping in mind that a test descriptor can describe a test container or a unit test is probably mostly sufficient. All right, unique ID. Let's take a look at the unique ID. And each test descriptor must have a unique ID. Unique ID has a static parse method, static for engine method. All right, well, creates a static root method, etc., etc. Constructor, get root, get engine ID, get segments, etc. So unique ID is a complex ID that uniquely identifies a unit test or a test container. All right, having taken a look at the test descriptor interface, let's now, we took a look at the engine discovery request, we took a look at the unique ID. Let's take a look at the execute method and the execution request. class, it will contain a test descriptor, which is the root of the test descriptor hierarchy. It will contain an engine execution listener that we saw before, and configuration parameters which we saw before. Right. So that pretty much sums up on the basic level our test engine API. And we can see here that we do have a getID method, discover method, and the execute method. We don't have any more methods because those are default, and we don't need them for our fairly simple custom test engine. All right, so delving into the code within the discover method, we see that we declare an engine descriptor, and let's take a look at the engine descriptor. It extends abstract test descriptor, and that in turn implements test descriptor interface. So an engine descriptor, obviously, if we only have unit tests and no containers, that's our kind of base container, our root container that's always present in the hierarchy. And so we declare the engine descriptor, then what we do, we utilize our discovery request, and we say that we are going to get selectors by type. We choose to supply our tests via files in the file system. So we're using a file selector. And for each of those, we are adding a file, or rather not a file. What we are doing, we are adding a test descriptor as a child to the engine descriptor, which is the root of our test descriptor hierarchy. And we're using a custom test descriptor that we wrote that basically just implements the test descriptor interface. We get the name of the file, unique ID of the engine descriptor, name of the file, and we read all the content of a particular file into memory, which is a very inefficient way to do it, but the simplest and therefore the easiest to follow. All right, so that is basically how we construct the test descriptor hierarchy, which is synonymous with the discovery of our tests. And we return this test descriptor hierarchy with the engine descriptor being the root of the hierarchy. At that point, our custom test engine is ready to execute the tests, and we get the root test descriptor. We spin an engine execution listener because we need to supply it with information about the progress of our test running. Then we just basically inform it that the test execution was started, and then for each of the tests within our hierarchy, and remember we know that we got a two-level hierarchy, a root, and then we got a bunch of children which are tests. None of the children is a container, in which case we would need to drill deeper. So basically we got this two-level hierarchy, and for this two-level hierarchy what we're doing here is sufficient. So we cast the test descriptor which we get for each iteration to a custom test descriptor. We inform that the listener that execution is started on a particular test descriptor. And this is the gist of our logic of whether or not our test fails or succeeds. We basically say that if the first line of a file is equal to test with a capital T, then we acknowledge that the test is successfully completed. Otherwise, test fails. And here we are just saying that our container successfully finished running. Alright, so that's the gist of the discover and execute methods of our custom test engine. Now what remains is to show what are we using as the basis for our tests, namely where do we get the files that we later will see whether it contains test or not. Take a look at the tests folder. We have 10 files here, and all of these files will be passed to our custom test engine. But how will it be done? For example, when we use the console runner, we are going to issue a command that looks similar to this, where our JUnit platform console standalone.jar will be passed an arguments file, and within the arguments file we are going to include our custom test engine, and then we're going to provide some command line selectors, select directives in which we're going to select all of these files. Alright, that is how something like that could be done by using a console launcher class, which we're going to explore in a little bit. And that is how files to be discovered can be passed into our custom test engine. So in the next video clip, I'm going to take a look more at the engine discovery request. In fact, I'm going to take a look at implementations of discovery selector and discovery filter. The reason I'm going to break this content into a separate kind of file is that I will need to do a lot of searching and opening through jar files and decompiling, and when that happens, the IDE will consume a lot of CPU cycles, and even though I have an i7 and 16 GB of memory on the laptop on which I'm recording the course, it will not be enough, and what will happen, the IDE will take up an inordinate amount of CPU cycles and will suppress proper audio of the course. So I'm going to put them into its own separate video clips and just monitor that this does not happen, and I may have to make some pauses, like 30-second pause somewhere, to enable the IDE to wrap up its search and kind of for its CPU load to kind of quiet down. So thank you for sticking very attentively and very closely to this material. It is extremely important to understand it well in order to become a JUnit guru. I will see you in the next video clip. So in this video clip, we'll continue on our custom test engine experiment, and we're going to take a look at the types of selectors which are available to us as we do discovery of containers and tests. Let's go to test engine. Let's go to engine discovery request. And here let's go to discovery selector. Let's right click on it. Select go to implementations. Right, let's click in the upper right corner of this. And here we go. There we go. There we have the selectors that we're going to review. Right, so we have a class path resource selector. Let's do do it more conveniently. Well, it just basically selects the name of a class path resource, and the test engines can load resources from the class path. XML, JSON files, etc. Files within jars. You can read more about it in the reader mode of the Java doc. Class path resource selector, class path root selector. You can do just F4. Alright, it selects a root of a class path so that test engines can search for class files or resources within the physical class path, for example, to scan for test classes. Class selector, let's do F4. A discovery selector that selects a class or class name so that test engines can discover tests or containers based on classes. Next, directory selector. A discovery selector that selects a directory so that test engines can discover tests or containers based on directories in the file system. Now remember that if you're looking for a test engine that can discover test classes and unit tests, then it is better to not reinvent the wheel and to use JUnit Jupyter, because it already is a very comprehensive test engine provided by the JUnit 5 platform. Now, why would you want to write your own test engine? Well, if you need to preprocess your bytecode in a certain way, instrument the bytecode in a certain way, etc., then you could perhaps make a use case for writing a custom test engine that works with basically Java, with the test classes, with the various types of unit tests, etc. If you want to use custom annotations, for example, etc., etc., if you want to use your domain-specific annotations, etc., then you could make a case for writing a custom test engine that way. Or you can write a test engine, for example, that pulls tests from a database, pulls some files from a REST service, etc., etc., for example. So the possibilities are really limitless here. You can spin your own discovery selector, for example, etc., etc. So you could do a lot of things to kind of customize the way you process test classes or unit tests. And remember that the concept of a container doesn't necessarily need to stop at the test class concept. It could be a directory, for example. It could be a segment of a database table that, for example, with data that came in today, etc., etc. So it's very flexible. It is very very variable what you can say is a container for tests, and it is also very variable and flexible what you can say is a unit test. It could be a method within a test class, it could be a file, it could be a directory, etc., etc. So could be a row in a database, could be a file that you get or a piece of data that you get via a REST service, etc. So the concepts of containers and unit tests are very, very varied, and you can make them as varied as you would like. So that is just a word of caution that you don't get tied into thinking, oh, well, we're going to basically write a custom test engine to parallel JUnit Jupyter, for example. That is not the case. It really depends on your particular requirements, on your particular project, on your particular set of directions from management, etc. Alright, let's go to the next selector. It is file selector that, if you recall, we're using in our custom test engine. Basically, it's a discovery selector that selects a file so that test engines can discover tests or containers based on files in the file system. Next one is method selector. It's a discovery selector that selects a method or a combination of class name, method name, and parameter types so that test engines can discover tests or containers based on methods. Alright. Module selector is a discovery selector that selects a module name so that test engines can discover tests or containers based on modules. Well, you get a sense that somebody was kind of robotically writing this Java doc, but I think it is fairly self-explanatory. Nested class selector. A discovery selector that selects a nested class or class name enclosed in other classes, so that test engines can discover tests or containers based on classes. So that's basically a selector of nested classes. Nested method selector is a discovery selector that selects a nested method or a combination of enclosing classes names, class name, method name, and parameter types so that test engines can discover tests or containers based on methods. For example, if a Java method is provided, the selector will return that method and its method name, class name, enclosing class names, and parameter types accordingly. If class and method names are provided, the selector will only attempt to lazily load the class and method if get enclosing classes, get nested class, or get method is invoked. In this context, a Java method means anything that can be referenced as a method on the Java virtual machine. For example, methods from Java classes or methods from other JVM languages such as Groovy, Scala, etc. So basically you can pull in a bunch of methods. Let's say those are my unit tests. Next is a package selector. It's a discovery selector that selects a package name so that test engines can discover tests or containers based on packages. Unique ID selector is a discovery selector that selects a unique ID. If you recall, we saw that class. It's each container or unit test must have a globally unique ID within the JUnit 5 runtime across different test engines, containers, containers, unit tests, etc. It has a globally unique ID. Hence, you saw there that it has some segments, etc. So that test engines can discover tests or containers based on unique IDs. And the last but not least is the URI selector, a discovery selector that selects a uniform resource identifier so that test engines can discover tests or containers based on URIs. Now let's take a look at the test engines itself. It's an interface that we just basically implemented. Get ID, discover, execute, get group ID, get artifact ID, etc. So that should make the circle come full circle, and we get the complete idea that a selector is used by a test engine to discover test containers and test method and tests. All right. So let's close everything, close all tabs. This concludes our discussion of selectors, except to say that you're free to roll your own implementation of a discovery selector. And basically, in that case, you get an extremely powerful extension of the JUnit 5 platform. So in the next video clip, what I'm going to do, I'm going to look at the filter selectors, because once you discover containers and tests, you would like potentially, optionally, to filter them out, some to use only a subset of what you discover. Alright, in this video clip we're going to open custom test engine, go to test engine, go to engine discovery requests, and we're going to set our sights on the discovery filter interface. Right click on it, select go to implementations, Ctrl-Alt-B, click here, and we get it as a docked window. Alright, in all of these three locations it's exactly the same, so we get to take a look first at the package name filter interface. Click on F4. And that's a discovery filter that is applied to the name of the package. If you want to filter packages, you would use this filter. Alright, class name filter, they're exactly the same, but for classes, discovery filter that is applied to the name of a class. And you can see here for package name filter, we get static methods include package names, exclude package names, and overloaded exclude package names. For class name filter, we get include class name patterns, exclude class name patterns. Alright, let's take a look at the include package name filter class. It implements obviously package name filter, and what it does, it filters based on your desired name of the package. Package name filter that matches fully qualified package names that are prefixed by one of the package names provided to the filter. Alright. So basically it looks for certain packages or sub-packages of those package names that you provide to it. Alright, let's take a look at the exclude package name filter. And this one obviously does the same thing, but it excludes it. Package name filter that matches fully qualified package names that are not prefixed by one of the package names provided to the filter. Alright, so if you have a list of package names, you're going to get package names that are not this and are not sub-packages of this. Alright. Well, actually, what you're going to get you're not going to get packages that are this or sub-packages of this. So packages that are this or sub-packages of these packages will be excluded. Alright, that is how they implemented it. Next, we would like to take a look at abstract class name filter, and that implements class name filter interface. Abstract class name filter that serves well, as a superclass for filters including or excluding fully qualified class names based on pattern matching. Right, let's take a look at the include class name filter. Class name filter that matches fully qualified class names against patterns in the form of regular expressions. So if you recall, in our previous, in part 1 of lab 7, we basically saw how the JUnit 4 runner filters including or excluding class name patterns. This one exactly works precisely in the same way. Alright, let's take a look at exclude class name filter. This is a class name filter that matches fully qualified class names against patterns in the form of regular expression. If the fully qualified name of a class matches against at least one pattern, the class will be excluded. It works in exactly the same way as exclude package name filter, except that it matches on the class names, whereas this matches on package names and its subpackages. I feel I wasn't 100% clear, so let me reread this package name filter that matches fully qualified package names that are not prefixed by one of the package names provided to the filter. If the fully qualified name of a package starts with at least one of the package names of the filter, the package will be excluded. Alright, so matches here means does not filter out. Okay. Alright, and that's basically the pre-built discovery filters. You are, of course, free to roll your own discovery filter based on whatever parameters or requirements of your project, etc. Having reviewed discovery selectors and discovery filters, let us clean up the IDE workspace a little bit. Let's close that, close this, and let us take a look again at custom test engine, custom test engine configuration, custom test descriptor, and custom test execution listener. Alright, so we saw the custom test engine. Let's take a look at custom test engine configuration. In the custom test engine configuration, we are not going to reinvent the wheel. We are just extending Jupyter configuration. Well, let's take a look at that one. And here we see actually the properties we might see in JUnit-properties -platform.properties file. So that's basically the gist of it, and we get some raw configuration parameters, parallel execution enabled, is extension auto detection enabled, etc., etc. Something that we would like to know what our test engine can do. Alright, let's go to custom test descriptor. We already saw the abstract test descriptor class. Basically just implements test descriptor, and our custom test descriptor just adds a few pieces of data and returns file content, returns the type, which is always type.test, etc. Now custom test execution listener extends test execution listener, something that we need to take a look at. It has some methods such as test plan execution started, test plan execution finished, dynamic test registered, execution skipped, execution started, execution finished, reporting entry published. So just a listener class to get listeners posted about important events in the life cycle of running anything that deals with a test descriptor, such as processing a container, processing a test, etc. Right, having reviewed all of this, In the next video clip, we're going to basically take a look at how to run our custom test engine by using the console launcher, and we're going to run a command that looks similar to this, except we're going to correct our path to JUnit platform console standalone jar. We're going to review the arguments file, and in the video clip after that, we're going to take a look at custom test engine tests, utilizing engine test kit to test our custom test engine. Right, let's close all tabs and let us proceed to the next video clip. Well, this lab is the hardest lab of the course, and this is what makes you a JUnit master or guru. So you have to stick with the program, and let us try to run our custom test engine by utilizing a console launcher. For that purpose, let us review the console folder that I kind of pre-built and was downloaded along with the project from GitHub or downloaded via the course's website. So basically we have a command.txt file. This file contains invocation of the Java virtual machine, invocation of a jar file, and the passing in of a arguments file. First things first, obviously this is not where we placed our JUnit platform console standalone jar. Let's take a look where that is. Let's go to external libraries. Let's open this, and let's take a look at this jar. Let's select copy path, and let's select absolute path. That is in fact where your copy of the jar will be located. Let's click on it, and let's replace this line within the parentheses with the line which we just selected. Please notice if you have a space here, obviously the parentheses are required. Now let's go to View, I believe, to Windows, Terminal. You can also press Alt F12. Let us, well, it got open in console. If it didn't open in console, you would put something like this, where dot is the path to the console folder. For example, if it opened like this, you would go to CD console. Alright, and let us now try to run this line and see what happens. So I did Control C, and here I'm going to do Control V. Where is the number 4 key from? Pardon me. I'm going to, well, this 4 got in from somewhere where I don't know it got in from. Well, I probably just typed it by accident. So that's our invocation via terminal window, via command line of our custom test engine. Let's click enter and let's see what happens. Alright, so we see, let us scroll up. After a brief delay, we see that our command caused several lines. Our custom test execution listener started to inform us about what is going on. And number of tests that were found is equal to 10. So we are surely talking about these 10 tests. And it runs these tests. And as it runs these tests, it gives some information, gives duration, status, etc., etc. And it runs all of these tests correctly, except one, the last one. It gives us the error that is output. It gives us duration, status, etc. And it says my custom test engine finished after 1 second, 87 milliseconds. Remember that we are not doing JUnit Vintage or JUnit Jupyter. We are actually doing custom test engine. And here it gives us a line that this is my custom test engine. All right. So then it gives us basically a readout of everything that happened. It found one containers, it started one container, which in our case is the root engine container. It says one containers was run successfully. That doesn't mean all tests pass, it just means that the run was successful. It found 10 tests, it started 10 tests, 9 tests were successful and 1 test failed. So that's the result of the running of our custom test engine. Now let us take a look at what arguments we passed to our custom test engine. We instructed first and foremost the console launcher, which is the class that is doing everything behind the scenes as we are giving commands. We instructed it to include custom test engine, and we didn't need to do this, but we instructed it to exclude JUnit Jupyter and JUnit Vintage. Right, we instructed it to select file test1 through test10. We used the select file directive 10 times. We gave the command to disable ANSI colors. It's just a minor detail. We wanted verbose details, and you can agree we got verbose details. We instructed there to be a report, to be placed in the same directory as where we're running from. And we gave the class path to the GRG-001 test unit as a habit test engine.jar. That is actually interesting. So we used this project to create a jar, which we ran by using this setup. So test custom test engine.xml just gives us an XML version of the run of our custom test engine to be parsed by the IDE by custom application, or by custom anything that wants to know how we ran our tests. Alright, let's delete this. It will still be created the next time we run it. Let us now take a look at where we're getting the custom test execution listener. Where are we getting it indeed? Because I don't believe we used it in the source. Let's take a look. Did we used an engine execution listener, but we didn't use a custom test engine. custom test execution listener we didn't use. So where did it come from? It came from here. Now remember, we are preparing a .jar file out of this project, and by running this command we are using this jar file which we are specifying here, in fact. So within the meta.inf folder and services subfolder, under that folder we have two classes. We have not classes but two files: org.junit.platform.engine.testengine, and here we are specifying the fully qualified path name to our custom test engine. And we are also using a file called org.junit.platform.launcher.testExecutionListener. And we are providing a fully qualified class name to our custom test execution listener. And if we wanted, we could also provide more than one execution listener or more than one test engine within this file. All right, and they would be registered in the order they were encountered in this. So this would be first. If you had a line number 2, that would be second, etc. All right, so that is where the log from the custom test execution listener comes from. And that is what is in fact in here. And that's what we are in fact seeing. All right, let's take a look. All right. On execution started, it says started executing a test, and that's exactly what, where is it, where did it go? That's exactly what we're seeing here. All right, and insofar as where this my custom test engine string is coming from, it's coming exactly from here, where we are providing a root descriptor for our test hierarchy, and its display name is going to be my custom test engine. All right, so that is how we can run our custom test engine by using a command line, by using the console launcher construct, console launcher class. So you can see that it gives us basically an output like this, and it shows us that we did well. And let's actually clear everything. Let's clear the buffer and let's run it one more time, just so we can look at it again. All right, so that we have repeatable runs. All right, so you can see that 10 tests were started, 9 tests were successful, 1 test failed. All right, in the next video clip, we're going to take a look at the custom test engine tests, because once we write a test engine, we must provide data that will know how it should behave if the test engine works correctly. For example, in here, we should be able to understand that we know that 9 of these test files contain tests starting with a capital T, and the 10th file contains tests starting with a small t. So when we run this, when we select these 10 files and we run our test engine, we should have it pick up 10 files, 10 tests. We should have it pass 9 tests, and we should have it fail 1 test. This is what happens here. However, this is not a test of our test engine. We need to be able to test it somehow, and that's where the engine test kit class comes in. So let's see how we can test our custom test engine. Alright, let's take a look at the custom test engine tests class. Let's take a look at our unit test. Yes, we can use unit tests to test our custom test engine. So let's take a look at our first unit test related to our custom test engine. Verify custom test engine container stats. And here I immediately write that you should provide your own absolute or relative paths to the test.txt files. Let's see how we can do it. So that's the path which I have for my own project. They should be in the same folder. So what we should do is we should copy this path, right click on the folder, do a copy, and copy path, and do absolute path. And then you just put the absolute path here. And remember, we must have, if you're on Windows, we must have double backslashes. So that's what we must do. Alright, and let's, in my case it's the same, in your case it may be different, so I'll just do it for each one of those. Let's change the path to the test.x.txt file. Now in my case, again, it's exactly the same because I obviously was creating this content before I was recording it. So in your case, it might be, it will be different. In my setup, I have a C drive and a D drive. And obviously I chose to put it on the D drive in case my C drive gets corrupted. That's where the operating system is. Alright, so we have now corrected the absolute path. It's better to do an absolute path because relative path, you have to take into consideration that whatever you're running is going to be in your out folder, not in your source folder and not in your test folder, etc. So absolute path just easier. Alright, then so we pick the engine, new custom test engine. You can also do the string, but in that case you have to watch the path. It has to be on the path. And since we are testing the same project, it's just easier to instantiate a new instance of it. Then we provide selectors, select file, and recall that we talked about selectors previously. If you go here and you do control space, you will see all sorts of selectors that are going to give you the different selectors that we saw previously. So we select all these files, then we say run, and then we say get as container events, and then we are going to assert statistics that we started one container. If you recall, that's exactly what we did. We started the root container and the root container succeeded. Right, that's our test number 1. Our test number 2 is verify custom test engine test stats. So we verify the container stats here, and here we verify the test stats. And again, I say you should provide your own absolute relative path to the test.txt files. What we're going to do, we're going to just copy what we did here, and we're going to paste it instead of these selections. Alright, so we again instantiate a new custom test engine. We select the 10 files, we run it, we get the test events, and we assert statistics that we started 10 unit tests, 9 of them succeeded, and 1 failed. Alright, let us now run this test class that tests our custom test engine. Of course, in a real life, you would test it with many more test methods, etc. But for our very simple custom test engine, we're just going to do a fairly simple two test scenario. Let's run it. And we see that both tests pass. And that's exactly what we would expect, because as we saw before, when we ran it using console launcher, we had one container, and the container succeeded. And also, when we ran using the console launcher, we did start 10 tests, 9 succeeded and 1 failed. So, and we ran using this data set, file set. So we know that our unit, our custom test engine, at least in terms of what we're testing here, works correctly. All right, this concludes part 2 of lab 7. It is the most difficult lab, obviously, that we can have. And congratulations if you're following me, understanding everything, and if you're doing well in that regard. In the last video clip, what we're going to do, what we nearly always do, we're going to retype certain names of classes, interfaces, etc., etc. All right, so we're almost done, and let us retype certain class and interface names so that we use our motor memory to utilize the API more effectively, because hopefully we will retain it well. Let's retype engine test kit. Let's just start from where we left off. Now, obviously, don't worry that it's semantically incorrect. We're going to delete it. All right. What else are we going to do here? We can do select file, but let's constrain ourselves to the API in terms of classes and interfaces. Let's go to custom test engine, implements test engine. Let's retype test engine 3 times. Don't worry that it's causing an error. I mean, obviously we're going to delete it. Let's write test descriptor. Test descriptor 3 times. Engine discovery request. Unique ID. Engine descriptor. We're going to leave selectors for a little bit, excuse me, later. Oh, execution request. Alright. We already did test descriptor. Let's do engine execution listener. Alright. Alright, and I think we let's do test execution result. Alright, now let us go to file selector and let us get the implementations. Alright, let's close file selector. Let's clear an area here. And let's do first class path resource selector. Alright. Next, let's do class path root selector. Like anytime I type, and I type with more than 2 fingers, but you know, if you can invest some time and money into a good typing program, that's just a major boost to your productivity. Class path root selector, class path root selector, class path root selector. Alright, class selector, class selector. Next is going to be directory selector. It is good for you that I don't type with all 10 fingers, because if you do, then you're keeping up with me just fine. If you're not, feel free to repeat this exercise, because you know this set of strings we need to type out. Feel free to freeze the course and feel free to type it on your own time. Method selector. Module selector. Alright, nested class selector. Nested method selector. Package, wait, let's wait a second. Okay, there you go. Package selector. Unique ID selector. And URI selector. Alright, let's delete everything. And let's now take a look at not selectors, but filters. We need to go to engine discovery request. That's where we can have a filter. Right, implementations. Let's close this and let's retype them. Now let's retype them like this. Package name filter first. Class name filter. Those are the interfaces. Then we're going to do include package name filter. Include package name filter. Include package name filter. Then we're going to do exclude package name filter. Exclude package name filter. Exclude package name filter. Then we're going to do abstract class name filter. Abstract class name filter. Strictly speaking, we don't have to do this, because the idea is to know the endpoint filters, not the hierarchy, but it won't hurt. Include class name filter. Include class name filter. Include class name filter. And exclude class name filter. Exclude class name filter. Exclude class name filter. Alright, let's delete it for sure, so that we don't get any errors. I think we got everything. We did this too, then we did this too, then we did this one, and then we did this too. Yeah, and we're done. Alright, what did we miss? We always missed something. Let's do, we did test descriptor, don't worry about this one. Well, actually you have to extend it, so let's do that. It's always nice when the API writer provides an abstract class of some sort containing parts of what needs to be implemented. Okay, that we did. What's next? We need to do type equals test. Type equals test. Type equals test. Alright. And we did type equals container. There is another type, container and test, but let's just type test and container. Container. Alright. And we are good to go. Alright. Let's see. What we need to do. Container and test is applicable to dynamic tests, I think, because a test method can produce lots of dynamic tests. Alright. Custom test engine configuration. Let's do Jupyter configuration. Oops, I did something here. Let's do it in the same way. Jupyter configuration. Right. Let's do custom test execution listener. Let's do, did we do test execution listener? We did engine execution listener, but I don't think we did test execution listener. So just wherever we have space, let's do that. Let's do it here. So that's most of our API that we hopefully will remember. Of course, you won't remember it verbatim in a motor memory type of way, but once you get to use it, you will recall. And that's basically what is the purpose here. Alright, close other tabs. Let's see if we did everything. Well, in the services subfolder of the meta.inf folder, we have these two files, and let's actually write them down. Also, file names, so that we remember. Org JUnit.platform.engine.test engine. That's the name of the file, not of a class. And you put a list of your test engines there. Well, we put one there. Org JUnit platform. And that's what you will do. You will put one test engine, unless you're a test engine writing fanatic. Alright, and the other one where we put one or more test execution listeners is going to be called org.JUnit.platform.launcher.test execution listener. That's the name of a file, not a fully qualified class name. JUnit platform launcher test execution list. org.JUnit.platform.launcher.test execution list. Alright, that was quite a lot, and you probably won't memorize everything unless you have perfect memory, but your motor memory will memorize enough so that when you will have started to do this by starting to type, you will in fact recall something, and that's the idea. Alright, and we are done with part 2 of lab number 7. So we're beginning part 3 of lab number 7, which together with lecture 7 form the most complex segment of the course. At this point, JUnit and JUnit 5 more precisely for us is definitely more of a habit and not an afterthought. And so let us go to the project website and let us go to launcher code. And let us clone or download the GRG-001 JUnit as a habit launcher project. This is the 4th and final project in the course, and it is required for lab 7 because we were absolutely forced to compartmentalize our code base so that a student of the course would not get lost amidst different purpose codes, which would have been otherwise in one project and very difficult to follow. So let us, you have the option to either clone or download the project. If you download the project, unzip the project and just open it within IntelliJ IDEA as the existing source. We are going to clone it. The download option is there in case the cloning doesn't work for whatever reason. Then you would be expected to download it from the project website. Alright, so let us go to the IDE. Let us go to File, New, Project from Version Control, URL. Let's paste the URL. And also let us see that all of these projects are in the same folder. So whatever the name the IDE picks is fine, but they should all be in the same folder for convenience. Okay, let us click clone, and it's cloning. Now it's asking where we want to open the project. We want to choose new window. So we want to have two windows. All right, and so let's take a look at what we have here. We have a custom launcher class and another custom test execution listener class. We also have tests, just like we had in the previous part. So we duplicated all the tests from the GRG-001 JUnit as a habit test engine project. These are the same files. We are doing it just for convenience's sake, because we are planning to invoke our custom test engine in the context of this file path. Alright, first order of business, go to File, Project, Structure, and let's see that everything is fine. So we're using Java version 14.0.2. Our modules are correct. So we have libraries. We have, please notice we have three libraries. One is our JUnit Jupyter platform. The other one is the platform console standalone. And the third one is the jar file we created in part number 2. So which we are picking up from the location of that project. All right, if any of these libraries are underlined with wavy red, what you would do then, I'm not going to do it for the JUnit Jupyter because we already multiple times downloaded it into the central repository, .m2 repository. I am going to do it for this library though. If this is underlined and missing, what you do, you highlight the text box located next to the name moniker, you do Ctrl+C, then you highlight this library, you do minus, okay, you do plus from Maven, you do Ctrl+V, and we have to get the transitive dependencies. Let's get sources, Java docs, and we're going to download it, and we're going to place it within our project, which is the launcher project. All right, it downloads it to a central location, and we are good to go. Just in case, even though it's not missing, it's there, let's delete this one, press OK, and let's see how we can import it. We go to Java, we go to the test engine project, we go to the out folder, we go to the artifacts folder, and we go to the jar file, and that's how we import it. And we add it obviously to our project. Okay, we are good to go. Let's see, artifacts, we don't need any artifacts. We are good to go, and we are good to start. First, let us review the, well, in the next video clip, we'll review the custom launcher Java class. So let us take a look at the custom launcher class. Now the launcher API is designed to enable a IDE writer to integrate the JUnit 5 platform into his product. Also, it has the same functionality essentially as what you would expect when writing a JUnit 4 test suite. So it can be used that way as well. Let's take a look at how we are going to launch our custom test engine from the previous part by using this custom launcher in the launcher API. First, let's review the main method that we are going to invoke. We create a custom launcher, we configure the custom launcher, we obtain a test plan of custom launcher, and a test plan is something actually that basically the container, the platform outlines how it's going to run, is a hierarchy of tests. And then we actually run the launcher and we run the tests. So now let's take a look at the configure method. It returns a launcher, and basically we provide a path to output the results of the test. We also provide a print writer to output the results of the test to the system out console. Then we create a launcher config object, and we build basically in the way that we do not enable test engine auto registration. We do not enable test execution listener auto registration. We add the test engines, new custom test engine. We add test execution listeners. Well, if we did through here, we wouldn't need to add test engines. If we did through here, then our custom test execution listener from previous part would have been out discovered, because remember that's what in the metainf.services subfolder. So our custom test engine would be auto discovered if we did true, and this execution listener would be auto discovered as well. But we did both of them false. We add test engine manually, new custom test engine, which is what we wrote in part 2. We added a test execution listener, new legacy XML report generating listener, which is what generates our XML report, and we want it to be generated in the directory, and we wanted it piped out to system.out. And we also add another test execution listener, another custom test execution listener, and we build the launcher config, and we create a launcher from launcher factory create, and we pass launcher config as the parameter. So once we have configured the launcher, it is the time to discover our unit tests and to create a test plan. And then we could use this test plan to output something to the UI, to a file, wherever, and how we're going to run our tests. Let us take a look at the discover method. We do the launcher discovery request, and we utilize the method discovery request, and let's take a look at the method discovery request. So here, that's where we discover the objects that will be part of the test plan and later of the execution of the tests. So here you see that we should provide our own absolute relative path to the test x.txt files. And let's do so. Let's there in our tests folder, let's right click on tests, copy path, and let's select absolute path, and let us paste it into here. For me it is the same because obviously I was creating this prior to recording this, and so we will put this absolute path to all the 10 files that we are discovering. Right, we are using select file method, just as in the previous part we did. Right. All right. And we are building a launcher discovery request. Now, when we return the launcher discovery request, we're returning it here. We're returning it here, and we are doing the discovery. Now, if you see here test plan, it is a class that contains basically what we have discovered. But you will notice here that we are not running anything, and we are not using the test plan in any way. We're just returning it. For example, we could parse it later on, and we could output to the UI what we have discovered and what will be run, for example. But in this case, we are just returning it without doing anything with it, and we're just logging that discovered some test and whether or not test plan contains tests. All right, and then we are executing the unit tests. However, what we are doing is we are again invoking discovery request, and we are registering a test execution listener, and we are invoking launcher.execute and executing the launcher discovery request, and that launcher discovery request will be run and executed in the same instance. So now we're getting an instance of test execution summary from the listener, and we're just outputting that found this many tests succeeded, this many tests failed. So just basic statistics about the running of our tests. All right, let's look at, well, actually, let's run this custom launcher, and then let us take a look at the API in more detail. Right, we have done the absolute path here, so it should be okay. And let's click on line 27 and select run custom launcher.main. And let's see what happens. If we did everything correctly, it will work fine. All right, we see here that some tests were discovered, and then we registered another custom test execution listener. It's kind of taking over, and it's telling us that it's executing some tests. And basically, if you recall it, discovered 10 tests. Here it's telling us the test plan execution is finished, and it's telling us that from here. These lines are telling us that it found 10 tests, 9 of them succeeded, 1 of them failed. And if you recall, that's the same result that we had in part 2. So remember that if we have as the first line the word test and it's capitalized, then it is successful. If we have anything else, it is not successful. All right. So we have run it. Now let us take a look at the results of the run. All right, let us take a look at the results of the run, which was output into the tests directory. So we had the results of the run in the console, and we had the results of the run as an XML file as we requested. And that's exactly the same as we did in part 2, except it was invoked in a slightly different way by using the launcher API, which was how it was invoked in part 2, of course only behind the scenes, because that's what IntelliJ IDEA did for us. Alright, so that is the custom launcher.java. Let's, for the sake of completeness, look at the listener. Another custom test execution listener. And just like any test execution listener, it just contains this just implemented methods that state in a very simple way what this particular method run signifies. For example, execution started, we know that the runtime started executing the test. Execution finished, we know that the runtime finished executing the test, etc. Reporting entry published, we know that the runtime published the reporting entry. Alright, and please notice that there are only 2 classes here and 10 test classes. So part 3, even though it contains tremendously powerful stuff, is fairly short. And in the next video clip, we're going to take a look more at the classes and interfaces, or interfaces and classes of the API. So let us take a look at the most important interfaces and classes of the launcher API. First and foremost, let us look at the launcher interface. Control click. This interface basically just is an instance of the implemented launcher of some kind. It allows you to register test execution listeners, to discover tests within a test plan, to put them, and to execute tests, and to also execute them in a different way. Alright, so what we're going to do now is we are going to take a look at some of interfaces and classes which are part of these methods. Let us take a look at the test plan. Right, the test plan is a class that basically contains information about the test container and test method or file or whatever is a test under your requirements. It basically gets that information and stores it within itself. Right, it has methods from, where it gets the collection of test descriptors. You can get roots. Obviously, you can have several hierarchies. You can see the test descriptor interface. You can see the test identifier, and let us take a look at the test identifier. So the test identifier is an adapter for a test descriptor. Basically contains nearly the same methods, and it just was done to bring these two concepts together. Alright, you can get parent, get children, get test identifier, count test identifiers, get descendants, contains test, etc. So we can navigate the hierarchy or hierarchies of tests that were discovered. Please note it can handle more than one hierarchy, and the launcher API can handle more than one test engine running when the launcher API executes. Alright, let's go back to launcher class. Let's take a look at launcher discovery request. It basically launcher discovery request just has several methods: get engine filters, get post discovery filters. This doesn't do anything, and maybe it will in future versions of JUnit. And get discovery listener. Let's take a look at an engine filter. An engine filter just basically has include engines, exclude engines, and apply. Methods in its public API. Right, it basically filters test engines. Now let's take a look at the post-discovery filter. It doesn't do anything and doesn't implement anything as well. Is not implemented by anything as well. So still waiting its time, I guess. Excuse me. Alright, we have an engine discovery request, which basically what we saw before: get selectors by type, get filters by type, get configuration parameters, get discovery listener. So the launcher API and the test engine API are somewhat intertwined. We have a launcher discovery listener, which listens to the launcher discovering engines and whatever tests you ask it to discover. It has two methods basically: engine discovery started and engine discovery finished. Right, and so implementations would provide some sort of functionality here, otherwise it's a no op. Alright, launcher.class test execution listener we saw before, so we can just go ahead and test plan we just saw. We can go ahead, we can skip the test plan. Launcher we saw, launcher discovery request we just took a look, test plan we saw. Alright, launcher discovery request, summary generating listener. Let's take a look at it. It's a class that basically allows you to get a test execution summary. Otherwise it has those methods we would expect a test execution listener to have. Let's take a look at the test execution summary. It has this interface. Once implemented, will provide interesting information such as anything you wanted to know about the containers and the tests that have been run, such as get time started, get time finished, get total failure count, get containers found count, etc., etc. You're very welcome to pause the progress of the course and to just review these methods. They're self-explanatory. You will also notice that there is no Java doc. That's because we are decompiling it as we go. Alright. we're going to skip on mutable test execution summary just because it's an internal detail. Right, test execution summary here we have. Now let's take a look at the launcher config. And launcher config, basically you're just telling the launcher API what actions are allowed and what actions are not allowed to perform. Such as enable test execution listener auto registration that we saw, enable test engine auto registration, add test engines. Here you can see that basically our launcher API can handle multiple test engines at the same time, etc. Right. Let us go on. Let's take a look at the launcher factory. It just basically builds launchers. Right. Using launcher config class. Right, launcher discovery request, I think we just saw it. Launcher discovery request builder, yeah, we just saw it. Launcher discovery request builder obviously builds launcher discovery requests. Right, and you can configure launcher discovery request as you see fit here. Alright, so in the next video clip, which is going to be the last video clip of Lab 7, we are going to retype several times the classes that are part of the launcher API, at least the main ones that we can see once we are typing launcher API code. Well, in this last video clip of Lab 7, we are going to retype certain interfaces and classes of the launcher API. Those that are visible, we are not going to drill into a tree of interfaces and classes, etc. So first, let's type launcher. And let us type it 3 times. Okay. Next, let us type test plan. Right. Next, let us type launcher discovery request. Right. Test plan we already saw. Summary generating listener. Alright. Test execution summary. Right. Launcher config. Launcher factory. Right. Launcher discovery request builder. Great, and let's see if we missed anything. The test plan. Let us see what's in another custom test execution listener. A test plan, we have test identifier. Test identifier. Test identifier. Test identifier. Right. Test execution result. Let's take a look at it actually. It says successful, aborted, failed, etc. We've seen it before. Let's type it. Right. And report entry. Let's take a look at it. It's basically something that is output to the sources of output that you defined. All right. Let's retype it 3 times. All right, and there are many more classes which are part of the Launcher API. However, they're not as visible as the ones we have just seen. So we are not going to retype them, but we are going to keep them in mind, and I urge you to spend more time to browse the Launcher API, to memorize it, and of course, don't expect, unless you have perfect memory, don't expect to memorize everything, but once you are doing something with it, it will come back and seem familiar or even clear. So this concludes Lab 7. It's been a very fine and fun journey, and I thank you for taking me along on this journey with you. Still, what remains is some appendices that contain interesting material, and perhaps check out some addendums in case some minor revisions of JUnit 5 have been done. They will be found in the addendums. So thank you again, and I hope this course was useful to you.